Today I have decided to redo an ISI 2019 B-Stat B-Math UGB problem, and the problem is prove that the positive integer n that cannot be written as a sum of r consecutive positive integers with r greater than 1 are of the form n equals 2 to the power l for some l greater than 0. Let us say we have r consecutive positive integers and the first term is a, so we'll have terms like a plus 1, a plus 2 up to a plus r minus 1. We can write this sum as r by 2, 2a plus r minus 1, and this is equal to some number n. Now we'll consider two cases. Case 1, when r is odd, and second case when r is even. When r is odd, let r be of the form, suppose 2k plus 1. So we can write this n as 2k plus 1 whole divided by 2, and then it will be 2a plus 2k, or this n will be 2k plus 1 a plus k, and clearly r is greater than 1, that means 2k plus 1, it is greater than 1. Now we consider the second case when r is even. So let r be 2k. In that case, we can write this number n as 2k by 2, 2a plus 2k minus 1. Now here 2 and 2 will cancel. We can write this number n as k into, now this is 2 a plus k minus 1. Now in both the cases, what we can see is this number n has odd factor. So this 2k plus 1, it is odd and it is unequal to 1. And here also this 2a plus k minus 1, this is odd. So this n, it must have an odd factor. That means n must not be of the form 2 to the power a, or it should not be of the form 2 to the power l. Now we have proved that this n, it cannot be of the form 2 to the power l. Now if it is not of the form 2 to the power l and it has at least one odd factor, so we can express this n as 2 to the power l into n, where m is an odd number and n is greater than 1. So we have proved that any number which is of the form 2 to the power l cannot be expressed as sum of r consecutive integers. Now we need to prove that for all other integers, that is all integers which are of the form 2 to the power l into m, where m is odd number greater than 1, they can be expressed as sum of r consecutive integers, and that is the second part of the question. Now we're going to show that any number which is of the form 2 to the power l into m, where m is an odd number greater than 1, it can be expressed as sum of consecutive integers. Now to prove this, we'll use a basic fact in AP, which is if A1, A2, A3 and AN, it is an AP, then arithmetic mean of numbers equidistant from beginning and end, they are equal. A2 plus AN minus 1 by 2. And suppose this average is A, and we know that sum of n terms of an AP, it is given by n by 2 A1 plus AN, and this Sn is nothing but it is n into A. So basically sum of these n numbers will be this n multiplied by their average. Now we'll come back to our question. Now we need to prove that any number which is of the form 2 to the power L into M, where M is odd and M is greater than 1, it is possible to have consecutive integers such that their sum it is equal to n. Now here we'll consider two cases. Case 1, when this M is greater than 2 to the power of L plus 1. Now here what we'll do is, we know that Sn is n into A, and we want this sum to be equal to n, and this n it will be 2 to the power L into M. So what we'll do is, we'll write this as 2 to the power L plus 1 into M by 2, and M is an odd number. So this M by 2, it is not an integer. So we'll construct an AP such that mean of terms from beginning and end, it is M by 2. And since we are talking about consecutive integers, so the middle two numbers, there will be M minus 1 by 2 and M plus 1 by 2. So that's your A, and this should be your N. So what we'll do is, we'll take 2 to the power L numbers here and 2 to the power L numbers here. Now in this case, this N, it will be equal to total number of terms 2 to the power L plus 1 into its mean, which is 2. So this N, which is 2 to the power L into M, can be expressed as a sum of consecutive integers. Now we'll consider the second case, when M is less than 2 to the power of L plus 1. Now in this case also, we need this sum NA, and it should be N 2 to the power L into M. Now here what we'll do is, we'll take M terms and we'll take this as average. Now since M is odd, it'll have middle term. So this 2 to the power L, so this 2 to the power L will be our middle term. So we'll construct a series 2 to the power L, 2 to the power L plus 1, 2 to the power L plus 2, and here will be 2 to the power of L minus 1, containing M terms. And in this case also, this N, it will be equal to 2 to the power L into M. So in either case, this N, which is of the form 2 to the power L into M, can be expressed as sum of consecutive integers, and this is what we need to prove in this question.